All right, we're going to do a quick little demo of the laser scanner rig. So I've got a little 3D printed gearbox over here with a NEMA 17 stepper hidden underneath, and then a Logitech C920 camera over here, both with 3D printed mounts mounted to some hard to see in this lighting conditions, but some 2020 frame rail. Let me see if I can get a little bit of a better angle on these. Nah, arm isn't long enough to get better shot, so we'll leave it like that. So let's go ahead and run the program. Give you guys a demo of this from the start. We're going to pick our camera, and we're going to pick which serial port our laser stepper controller is set up on. I should now be able to turn on the laser. So the first thing to do is get this laser set to pointing straight forward or perpendicular to this frame rail. Oh, that's going really fast. So let's slow it down so I can actually get what I need. So I am going to eyeball this. There is no automatic process for determining laser position yet. That should do it. Yeah, that looks good. And now that it's 90 degrees, perpendicular, pointing straight forward relative to this frame rail, we're now going to set the right extent of the image of the area we're scanning. I'm just going to do the whole thing. So we'll go that far. We'll tell it to go back to home, and then we're going to make sure our camera properties are set to give us the best laser scan image. I'm going to go back to the right a little bit, because I do want to make sure it can pick up this arm better. So first thing we're going to do is we're actually going to turn the laser off, turn the blur up to 4, save a base image. Now when we turn the laser on, we can see areas that have just become brighter due to the laser line emitter. And if we look at the threshold, you can see we're getting some lines there that might be picked up. And in the scan, that's pretty good coverage for the arm. And we can sweep that back and forth a little bit. And it looks like it's getting good enough coverage that we'll be able to recognize it in the scan. So let's go ahead and sweep this laser off to the left. I'm going to set that as the left extent. It doesn't really do anything. The left extent does not need to be set to use this. It's just a convenience if you want to rescan. You can hit the go to reset the position instead of having to manually drive it back to the left. So just going to make sure we still have when we're looking at the difference, we still have a nice dark area. There's no highlights showing up or anything like that. And everything's set, so we're going to start a scan. This is now per camera frame that it's grabbing. If we look at this position, every camera frame, it's stepping the stepper motor. And now that the laser's starting to show up in the scene, we can actually see the relief of these blinds that are in front of this window on the back edge of the desk. The way this depth map works is it does rescale the closest item it's seen so far to the brightest white, and the furthest item to 0, so the darkest black. And every frame it gets, it's going to be continually rescaling things. So particularly back here and maybe even the screen, you'll see it adjust its grayscale color. That is normal and expected. Towards the right, this camera isn't quite perpendicular to the window that's behind the desk. So it will start showing the blinds off on the right side of the image, which you can't even really see in this image, but these will be a little bit lighter than the blinds on the left side of the image. But this is it. We can basically sit here and wait now. It's going to be moving, moving this all the way until it gets to position at negative 92. So this is using a little Arduino board. I'm pointing at something, but it's not quite in view. So down under here, under this gearbox, there is an Arduino board, which is connected up to a Pololu stepper driver, which is driving the stepper motor that is at the bottom of this end of the gearbox. This is a 3D printed 1 to 8 gear reduction gearbox. The Pololu stepper driver is configured for doing 16th micro stepping. And we can see here in the stepper parameters that those are what's entered. I'm not telling the system what the angle per step is. I'm letting it calculate it based on the stepper and gearbox parameters. If we can see here, there is some banding here. Trying to do this all the way to 16th microsteps does cause some jiggling of the laser as it sometimes takes a step or doesn't actually move, which will affect some of the distance readings a little bit. But by and large, it works pretty well. So obviously brighter objects, brighter pixels are closer to the camera, darker pixels are further away. You can see we're getting a little bit of a reflection here. This was probably showing up just as the laser was starting to reflect off of the edge of the laptop screen lid. But eventually this should get all, well, no, these are back on the blinds. But we'll see this camera boom arm should get filled in pretty decently. Right now the desk surface is showing up really well. That's a really nice, sharp, crisp line there on the desk. And we can keep flipping back and forth through all these different stages of processing just to get an idea of what's going on. In fact, with all the lights in this room pretty much turned off, the only light I have is monitor light. It's actually kind of hard to see what's going on except for immediately where the laser is. We must have picked up some noise somewhere around in here. Right around in here somewhere, every time I do this scan, I've been picking up some noise. There is a robot vacuum cleaner LiDAR unit sitting right here. And we get some light reflections showing up over here for some reason. Not sure what they're showing up off of, but it does cause it to read as really far away, which does kind of flatten all of the image. Again, this depth image is getting rescaled every frame we retrieve. Now, as this starts to fill in this LiDAR unit, once this scan over here reaches somewhere around in this vicinity, we should see it rescale everything properly. This is still kind of a good view because we can see that everywhere that's white has been touched by the laser. So aside from where it's like this side of this oscilloscope box on the bottom is actually just too far to the right that the the laser can't ever hit this edge. We can see this separation right here. That's just the offset of the laser being far enough to the left of the camera that this dark area is the shadow of the laptop monitor lid. This is the shadow of this boom arm. Okay, there we go. We can see we've fixed that noisy reflection we picked up. Everything rescales a little bit better. So here's the camera arm. So this camera is currently sitting on this arm. And here's that arm shadow. So since the laser can never hit this spot, this will never get filled in. Right, here's the LiDAR unit. It's sitting on top of some 3.5-inch hard drives. We can see there's 2 cables coming out the right side of this netbook, one of which is actually the camera that's on the top of this boom, this arm here. That's actually, this camera is attached to the netbook that's visible in the scan right about there. And I've got it recording in OBS using MJPEG Streamer. Then we're just getting the closer arm of this PCB holder. Really great for soldering with. And shortly here, we're going to start getting some weird reflections off of the reflow gun and the soldering iron that are sitting over here on this right side of the image. It's going to probably cause some noise to show up. Yeah, you can see we're getting some weird artifacting, and we can see that we're getting definitely noticeable reflections of the laser line. Shiny objects using this technique are going to cause problems. But for the most part, gives us a pretty nice scan. Really dense. We could see there's only a couple of spots where we're missing a vertical set of pixels, but it's got really good coverage. We should be getting, we're getting pretty close to our right extent now. This is set up so that once it reaches this, it will turn off the laser, turn off the scan mode, and now we're free to reset everything. So I can go ahead and tell that laser to sweep back to the left. I could turn on and off the laser. Thanks to telling the Arduino to go to a specific position, we can then continue to send it other commands. But here we go. There's the functionality of this laser scanner app so far. Now pretty much all that's left is to add some code to turn this into a point cloud instead of just a planar depth map.